Now we'll begin with the chapter binomial distribution. We'll start with level 1 questions which are easy type. So first is, let P be the probability of happening of an event and Q of its not happening. Then total chance of R success in N trials, 0 is less than R is less than N is. So here an event is happening, let's say a match, and P is the probability of success, let's say winning, and Q is probability of not happening, that is failure. So we have to find the probability of winning R times when N trials are made, that is N games are played total. So this is a binomial distribution. So probability of finding the number of an event, probability of an event happening is P of x is equal to R, where x is the event which we consider, number of events that we want. Here we say R success. So it is NCR P raised to R Q raised to N minus R, where N is number of trials, that is number of games whatever it is played. Here it is number of trials. R is number of success that we want, and P is probability of succeeding, and Q is probability of failing, that is probability of the event happening, and Q is probability of event not happening. So the answer is A, NCR P raised to R Q raised to N minus R. Next question is, if X is binomial distribution of N comma P, where N is 10 and E of X is 8, then P is what? So firstly, binomial distribution is represented as N comma P, where N is number of trials and P is probability of success. E of X is expectation of the event which will occur, and it is given as E of X is equal to N into P. So here N is given as N is given as 10. So we substitute the value. So E of X is 8, N is 10 into P. We have to find P. So P is 8 by 10, which is nothing but 0.8. So the answer is B, 0.8. Next question is, X belongs to binomial distribution N is equal to 10 and P, and expectation of X is 5. Then we have to find the value of P and V of X. V of X is variance, and it is given as NPQ, which is equal to Q into expectation. So first we'll find P. So expectation is E of X is equal to N into P. So E of X is given as 5, N is 10, number of events, number of trials is 10, and P. So P is 5 by 10, which is equal to half. So only option among these is half, but it can also be none of this since we don't know the value of V of X. So we will also find V of X. So V of X is NPQ. But Q is, now we know that sum of all the probability of events is 1. So that is P plus Q is 1. This is equal to 1. Total probability is always 1. So P we have, it is 1 plus Q is equal to 1. Therefore Q is half, 1 minus half, that is. So we got Q. So we substitute this here. So we get N is 10, P is half, Q is also half. So we get 10 gets cancelled, we get 5. So answer is 5 by 2. So the variance is 5 by 2, which is option B. P is half and variance is 5 by 2. Now here binomial distribution is given as N comma P. Expectation is given as 5. Variance is 2.5. We have to find the value of N and P. So first we have v of x is npq, which is also given as npc of x. So we can also write e of x into q, which is v of x. So first we find q. From q we'll get p, and from p we can get n. So let's find q first. So v of x is 2.5, e of x is 5 into q. So q is 2.5 by 5. Now we know that 2.5 is half of 5. So we can write this as half. So q is half. Therefore p is 1 minus q, since the total of p and q is 1. So p we get this as 1 minus q, which is 1 minus half, which is half. So p is half, that is 0.5. So it can be either A or D. So let's check the number of trials. Now we know that e of x is 5. So e of x is n into p. We have p here, 0.5, that is half. So 5 is equal to 1 by 2 into n. Therefore n is 5 into 2, which is 10. Therefore we have n is equal to 10 and p is equal to half of 0.5, which is option A. The next question is, a die is thrown 5 times. If getting an odd number is considered a success, then variance of the distribution is, now the number of trials is 5, a die is thrown. So this is 5, n is 5, since the die is thrown 5 times. Getting an odd number is considered a success. Now we know there are 6 faces for a die, and half is odd and half of them is even. That is, there are 3 odd numbers and there are 3 even numbers. So probability of getting odd number from a die is 3 by 6. Since there are 3 odd numbers out of 6 faces, which is equal to half. So P, which is considered as success of getting odd number, is half. So P is half, n is 5. Now formula for variance is v of x is n into p into q. Now we got n, now we got p. We need q. So q is 1 minus p. So q is 1 minus p, which is 1 minus half, which is half. So q is also half, p is also half. So we get n is 5 into p is half and q is also half. So we get the final answer as 5 by 4, which is variance is 5 by 4, which is option D. The next question is, in tossing 10 coins, probability of getting exactly 5 heads is, now number of trials is 10. A coin is tossed 10 times and we are supposed to get head 5 times. So x is, or we can say r is 5. That is number of success we need from n events. So we need 5 success from 10 trials. Probability of getting a head in a coin toss is half, since there are 2 faces, heads or tails. So probability of not getting heads, that is probability of getting a tail, is also half. So we have P, which is half, Q, which is half, R, that is number of success, is 5, total number of trials is 10. So probability of getting 5 heads out of 10 trials is, as we have seen in the first question, it is P of x equals R, where x is 5. So P of 5 is equal to NCR. NCR, P raised to R, Q raised to N minus R. So this is 10C 5, P is half, raised to 5 into Q, which is half, raised to 10 minus 5. Now 10C5, there's a shortcut for writing the combination. We can write 10 into 9 into 8 into 7 into 6 divided by 5 into 4 into 3 into 1. Similarly, now this is 1 by 2 raised to 5, since 10 minus 5 is 4. So totaling it, we get 1 by 2 raised to 10. Now we simplify this here. So we get finally mm, we can cancel 2 from the numerator. So we finally get the answer as 63 upon 2 raised to 8. Now we don't know, some of you might not know what the value of 2 raised to 8 is. So that is not needed since the numerators are exclusive. So we'll only compare the numerator. So the numerator is 63 and it cannot be divided further by 2. So this is exclusive. So we'll check for the numerator. So option D has numerator 63 and this is 256 and 2 raised to 8 is 256. So the answer is D, 63 by 256. Next question is, probability that an event A happens in a trial is 0.4. If 3 independent trials are made, then probability of A happens at least once is, now probability of a trial of success for a particular event is 0.4. So P is 0.4. 3 trials are made. This is P, probability of an event A. So probability of A is 0.4. 3 trials are made. So N is 3. And we have to find the probability of A happening at least once. Probability of A happening at least once is, it can occur 1 or more than 1 times. So this will be written as X is greater than or equal to 1. Now probability of an event happening at least once is the same as total probability, that is 1 minus probability of event not at all happening, that is X equals 2. This is 1 minus none rule. Probability of an event occurs at least once is total probability minus event when it will not even occur. So probability of X equals 0 is the same as Q, that is probability of not happening, P not happening. So Q is 1 minus 0.4, which is P. So 1 minus P, Q is 1 minus P, so therefore Q is 0.6. Q is probability of P not happening, that is failure of event P, that is A. So this is nothing but 1 minus Q. Now Q is 0.6, so this is 1 minus 0.6. There's a correction, this is not Q. This is not Q. However, we will be using Q for finding this. So we'll find this independently. So P of X equals 0, that is event X not happening, is the standard method NCR P raised to R Q raised to N minus R. So here N is 3, so 3 C 0, here in case we have 0, P raised to 0 Q raised to 3 minus 0. Now 3C0 is 1, P raised to 0, anything raised to 0 is 1. So this we are left with QQ. So P of X equals 0 is QQ. Therefore, P of X happening at least once is 1 minus P of X equals 0, which is the same as 1 minus QQ, which is 1 minus 0.6 cube. Now 6 cube is 216. So we can write this as 1 minus 0.216. So the final answer is 0.784, which is option C. Next question is, mean and variance of a binomial variate are 4 and 2 respectively. We have to find the value of P of X equals 1. That is number of successes 1. So what is given is, mean is the same as expectation. So this is mean E of X, which is equal to N into P, which is 4. Variance is given as 2, which is NPQ. This is 2. So now we know variance is E of X into Q. So this is 2 is equal to E of X is 4 into Q. So Q is half. Therefore, P is also half. Since this is 1 minus half, 1 minus Q, that is. So P is half, Q is half. So we can find this. So P of X equals 1 is NCR P raised to R Q raised to N minus R, where R is 1. So now we also have to find n. So E of x is 4, P is half. So n will be 4 into 2, which is 8. So this will be 8. So P of x equals 1 will be 8C, R is 1, 8C1 half raised to 1 into half raised to 8 minus 1. So 8C1 is 8, and this is half raised to 1 into half raised to 7, which is the same as 8 into 1 by 2 raised to 8. Now 8 can be written as 2 cube. So this will be 2 cube divided by 2 raised to 8, which is, now 2 cube gets cancelled out. We are left with 1 by 2 raised to 5. Now 2 raised to 5 is 32. So the answer is P of x equals 1 is 1 by 32, which is option A. Next question is, mean and variance of a binomial distribution are 4 and 2 respectively. The probability of two successes is, now mean is given as, mean which is the same as expectation is given as 4. Variance is 2. We have to find the probability of two success, that is P of x equals 2. This is given as NCR P raised to R Q raised to n minus R, where R is 2. Using these two, we'll find N, P and Q. So we knew that variance is E of x into Q. So variance is 2, E of x is 4, and Q. Therefore Q is half. Therefore P is also half, since they add up to 1. This will be 1 minus Q. So P is half, Q is half. We'll find N. So E of x is 4, which is same as NP. P is half. So therefore this is equal to 4 equals N into half. Therefore N is equal to 8. So we have N, we have P, we have Q, and we also know R. So we'll find P of x equals 2. So this is P of x equals 2 is equal to NCR, that is 8, C, R is 2, P raised to R, that is 2, into Q raised to n minus R, that is 8 minus 2. So this is 8C2 is 8 into 7 by 2 into 1 into P is half into Q raised to 8 minus 2 is Q raised to 6. So this will be 1 by 2 raised to 6. So this will be 4 into 7 into 1 by 2 raised to 8. Now 2 raised to 4 can be written as 2 square. So this will be 2 square divided by 2 raised to 8 into 7. This is the same as 7 by 2 raised to 6. Now 2 raised to 6 is 64. So this will turn out as 7 by 64, which is option C. Mean and variance of a binomial variate x are 2 and 1 respectively. So what is given is E of x, that is mean, is 2, variance is 1. The probability that x takes value greater than 1 is, we have to find the probability of x having value greater than 1, that is x is greater than 1. Now this is the same as total probability, that is 1 minus probability of x equals 0 or probability of x equals 1. That is, the value should be greater than 1. So we can find this as total probability minus probability of x not occurring or x occurring once. This can be written in mathematical form as 1 minus P of bracket p of x equals 0 plus p of x equals 1. Now we find both of these. So first, p of x equals r is NCR p raised to r q raised to n minus r. Now we have to find np and q. Now we know that variance is e of x into q. Variance is 1, e of x is 2, so q is half. So if q is half, p is also half. Since this is 1 minus q, so p is half, q is half. Therefore, n will be, now e of x is np, e of x is 2, n is unknown, and p is half. Therefore, p will be 4. N will be 4. So number of trials will be 4. So we have n, we have p, we have q. So p of x equals r will be NCR. So this will be 4c2 p half raised to 2 into half raised to 4 minus 2. So this can be simplified as, this will be r and this will be r. So this can be simplified as 4cr, r can be either 0 or 1, into 1 by 2 raised to, this is r, we'll solve it again neatly. So first, p of x equals r, we'll find a general expression for success. So this will be NCR p raised to r q raised to n minus r. So r can be anything, it is either 0 or 1. N is 4, so 4cr, p is half and q is also half. So this will be 4 minus r. So r plus 4 minus r, this will be 4cr half raised to r plus 4 minus r. This is the same as 4cr half raised to 4. So this is for x equals r. Now for x equals 0, r will be 0. So this will be 4c0 half raised to 4. So now 4c0 is 1. So this will be 1 into 1 by 2 raised to 4. So let this be 1. Now we will find p of x equals 1. So put r equals 1 here. We get 4c1 half raised to 4. Now 4c1 is 4. So 4 into half raised to 4. So we substitute this here. So p of x greater than 1 was 1 minus p of x equals 0 in brackets plus p of x equals 1. So now p of x equals 0 is 1 into 1 by 2 raised to 4 plus p of x equals 1 is 4 into 1 by 2 raised to 4. We take 1 by 2 raised to 4 common. So we get 1 minus 1 by 2 raised to 4 common, 1 plus 4. So this will be 1 minus 5 by 2 raised to 4. So this will be, now 2 raised to 4 is 16. So this will be 1 minus 5 by 16. So this will be 11 by 16. So the final answer is p of x greater than 1 is 11 by 16, which is option C. A contest consists of 3 types of result: win, draw, or lose. So there are 3 possibilities: winning, drawing, or losing for 7 football matches. So for one match, a team can either win, draw, or lose. So probability of either of 3 is 1 by 3. Since total number of outcomes is 3, and there is one possibility. So 7 matches are played, so n will be 7 number of trials. Then probability that an entry sent by Hemant based on his random predictions will contain exactly 3 prediction is. Now we have a person named Hemant who is predicting the outcome of the match. So it can be either win, draw or lose. So we have to find the probability that he is right 4 times. So let us say he is predicting that a team will win the match. So let the probability of success, that is winning, which we are considering as the correct prediction, be 1 by 3. So probability of failure of the prediction is 1 minus remaining predictions, that is 1 by 3 minus 1 by 3, that is for drawing or losing. So Q will be probability of failure. So this will be 1 minus 2 by 3. This will be 1 minus probability of winning. So this will be 1 minus 1 by 3, which is 2 by 3. So this includes probability of drawing and losing and not winning. So P will be 1 by 3, Q will be 2 by 3. P is probability of winning and Q is probability of not winning. That is, the team will either lose or draw. So we have to find the probability that he is correct 4 times. That is, he is predicting that the team will win 4 times. So probability will be 1 by 3. Number of success events is 4. So R will be 4. Now, what we have to find actually here is P of X equals 4. Since R is 4, that is, we are supposed to make 4 correct predictions, and in this case we are considering the correct prediction to be winning. So this is NCR P raised to R, Q raised to N minus R. N is 7, so 7 C4 P raised to 4, Q raised to 7 minus 4. Rewriting the values, so we get P is 1 by 3, Q is 2 by 3, R is 4 and N is 7. So P of X equals 4 is NCR, that is 7C4, P raised to R, that is 4, Q, that is 2 by 3 raised to N minus R, that is N minus 4. So 7C4 is 7 into 6 into 5 into 4 divided by 4 into 3 into 2 into 1 into 1 by 3 raised to 4 into 2 raised to 3, 7 minus 4 is 3. So 2 raised to 3 by 3 raised to 3. 4 gets cancelled. 3 into 2 is 6. So simplifying these terms, we finally get 280 by 3 raised to 7, which is option C, 280 by 3 raised to 7. And this was P of X equals 4. That is, his prediction is correct 4 times, which in case we assumed the correct prediction to be winning. If 6 fair dice are rolled, then probability that at least half of them will show at least 3 is. So now we have to get at least 3 on each face. So P is at least 3 means the die should show these values, that is 3, 4, 5 or 6. So these are 4 possible outcomes. Total outcomes are 6 since it has 6 faces. So probability of success, that is showing at least 3, is number of possibilities is 4 divided by total number of outcomes, so 6. So P will be 2 by 3. Therefore Q will be 1 minus 2 by 3, which is 1 by 3. So now at least half of the dice which are thrown should show these numbers. So what we have to find will be P of X greater than equal to Now half of 6 is 3. So at least 3 dice should show these numbers. So this will be x is greater than equal to 3 dice. So this will be p of 3 plus p of 4 plus p of 5 plus p of 6. Or we can write this as total possible outcomes, that is 1, sum of possible outcomes minus probability of event not occurring, that is probability that 3 will not occur. 3 or greater than 3, the number will not occur, that is 1 or 2 will show up. The number 1 or 2 will show up on the face. So this will be sum of probability of phase 1 plus probability of phase 2. So now we find these values. So p of x equals r will be NCR p raised to r q raised to n minus r. So n is 6 here. Since the number of dice rolled are 6, so n will be 6. So this is 6 c r p raised to p, that is 2 by 3 raised to r into 1 by 3 raised to r n minus r, that is 6 minus r. We can write this as 6cr 2 raised to r into 1 by 3 raised to 6. So this is the general form for p of x equals r. Continuing, p of x equals r is equal to 6cr 2 raised to r 1 by 3 raised to 6. So for r equals 1, so this will be p of. Next question is, it is given that x is a binomial distribution where n is 5, that is number of trials is 5, p is the probability of success. If p of x equals 1 is 0.4096, p of x equals 2 is 0.2048, then the value of p is what? So first we'll write the general value for x equals r for any value of x. So this is given as NCR p raised to r q raised to n minus r. Now here n is 5, so it will be p of x equals r. This will be 5cr p raised to r q raised to 5 minus r. So for x equals 1, so it will be p of x is equal to 1. This will be 5c1 p raised to 1 q raised to 5 minus 1. But now we know that q is equal to 1 minus p, since sum of the probabilities is 1. So q is 1 minus p. We have to find p, so we'll write everything in terms of p. So we write q in terms of p. Now 5c1 is 5. P, this will be p raised to 1. Q raised to 5 minus 1 is q raised to 4, which is the same as 1 minus p raised to 4. Now p of x equals 1 is 0.4096. Now we'll form an equation in terms of p. So p into 1 minus p raised to 4 is 0.4096 divided by 5. Let this be equation 1. Now for p of x equals to, this will be 5c2 p raised to 2 q raised to 5 minus 2. Now q is the same as 1 minus 2, and this is q cube. So this is 5c2, that is 5 into 4 upon 2 into p square into q cube, that is 10 into p square into 1 minus p cube, and this is 0.2048. Let this be equation 2. Now we divide 1 by 2. So we get 1 divided by 2. So we get p into 1 minus p raised to 4 upon p square into 1 minus p cube into 10 is equal to, this is 0.4096 divided by 5, and this is divided by 0.2048. So now p gets cancelled. There's a correction, it is whole raised to 4 and this is whole cube. So 1 minus p raised to 3 gets cancelled here. So we are left with 1 minus p upon p. 10 goes here. So this will be 10 by 5 into 0.4096 divided by 0.2048. Now this gets cancelled. This is twice the denominator. Same goes for this. So now it is 1 minus p is equal to 2 into 2 is 4. So this will be 4p. So 1 minus p is equal to 4p. Therefore 1 is equal to 5p. Therefore p is equal to 1 by 5, which is option D. Next question is x belongs to a binomial distribution where n is 6 and p is the probability of success. Now p of x equals 4 is the same as p of x equals 2. We have to find the value of p. Now the approach will be same as the previous sum. So it is given that p of x equals 4 is equal to p of x equals 2. Now we'll write the general form for x equals r. So probability of x equals r is NCR p raised to r q raised to n minus r. Now q is 1 minus p. So this will be, now n is 6, so 6cr p raised to r 1 minus p raised to 6 minus r. Now for x equals 2, so this is p of x equals to 6c2 p square 1 minus p raised to 6 minus 2, which is 4. So this is 6 into 5 by 2 into p square into 1 minus p raised to 4. And this is p of x equals to. Let this be equation 1. Simplifying this, we can write 15p square 1 minus p raised to 4. And this is p of x equals to. Similarly, p of x equals 4 is 6c4 p raised to 4 q raised to 6 minus 4. That is, now 6c4 is 6 into 5 into 3 into 2 divided by 4 into 3 into 2 into 1. 3 gets cancelled, 2 gets cancelled. Sorry, this is 6 into 5 into 4 into 3. And this is the 4 gets cancelled. So we are left with 6 into 5 by 2 p raised to 4. Now q is 1 minus p. So this is 1 minus p raised to 2. Now there's a correction in the question. This is actually 9 times p of x equals 4 is equal to p of x equals 2. So here it will be 9. Now this is p of x equals 4. So this is equal to 15 times p raised to 4 1 minus p square. Let this be equation 2. So now substituting these, in a given condition, so we get 9 times p of 4 is equal to p of 2. So that is 9 times 15 into p raised to 4 into 1 minus p raised to 2 is equal to 15 times p square into 1 minus p raised to 2. 15 gets cancelled, p square gets cancelled, 1 minus p raised to 2 gets cancelled. This is 4. So we are left with 9p square is equal to 1 minus p the whole square. Simplifying this, we get 8p square plus 2p minus 1 is equal to 0. So now we get a quadratic equation in terms of p. So we find the roots to get the value of p. So our quadratic equation was 8p square plus 2p minus 1 is equal to 0. So roots of the equation is given as minus b, that is minus 2, plus or minus root of b square minus 2ac. b square, that is 2 square, minus b square minus 4ac. So 4 times 8 into 1 divided by 2a, that is 2 into 8. So this is minus 2 plus or minus 6 divided by 16. So p can have value as 1 minus half or half. Since this is a probability, so it cannot be negative, so this gets cancelled. This cannot be a value for p. So the answer for p is 1 by 4, which is option C, 1 by 4. Next question is, a binomial distribution is given, n is 4, p is not given, p of x equals 0 is 16 by 81. We have to find the value of p of x equals 4. So first we'll write the general form for p of x equals r. So this is NCR p raised to r q raised to n minus r. So now for x equals 0, it will be p of 0. N is 4, so 4c r is 0, so 4c 0 p raised to 4, b raised to 0. This is q raised to 4 minus 0. So 4c 0 is 1, p raised to 0 is 1, and this is q raised to 4. But p of 0 is 16 by 81, so this is 16 by 81. So therefore q raised to 4 is 16 by 81. Now 16 is 2 raised to 4 and 81 is 9 square, that is square of 3 square, that is 3 raised to 4. So this is 3 raised to 4, this is 2 raised to 4, and this is q raised to 4. So taking 4th roots on both sides, we can say q is 2 by 3. It cannot have negative value since it is a probability. So q is always positive, so it is 2 by 3. So therefore p is equal to 1 minus q, which is equal to 1 minus 2 by 3 is equal to 1 by 3. So now we can find p of x equals 4, which is 4c4 p raised to 4 q raised to 4 minus 4. So 4c4 is again 1 into p raised to 4 into q raised to 0. Now p is 1 by 3, so this will be 1 into 1 by 3 raised to 4 into 1. Now 3 raised to 4 is 81, so the final answer is 1 by 81, which is p of x equals 4. So the answer is B, 1 by 81. Next question is, 100 identical coins, each with probability p of turning up heads, are tossed, where p lies between 0 and 1. If probability of heads showing on 50 coins is equal to probability of heads showing on 51 coins, then p is what? So now we cannot say p is equal to half, since we are not given the information that the coin is fair. It can be either both side heads or both side tails. So p, we cannot say for sure that p is half, so we'll have to find it the other way around. So first we are given that 100 coins are tossed, so n will be 100, number of trials is 100. Another thing which is given is probability of heads showing up on 50 coins is the same as probability of heads showing up on 51 coins, which is p of x equals 51 is equal to p of x equals 50. So now we apply the formula NCR p raised to r q raised to n minus r. So here q is 1 minus p, we substitute directly here. So it is NCR, that is 100, CR is 51, p raised to r, that is 51, q, that is 1 minus p raised to n minus r, that is 100 minus 51, which is 49. This is equal to NCR again, 100 C 50 p raised to 50, 1 minus p, which is q raised to 50, that is 100 minus 50. So we simplify this. 100 C 51 is n factorial upon r factorial into n minus r factorial, that is n factorial upon r factorial into, that is 51 factorial into n minus r, which is 49, 100 minus 51, so into 49 factorial into p raised to 51, 1 minus p raised to 49. This is equal to 100 factorial upon r factorial, that is 50 factorial into n minus r, which is 100 minus 50 factorial, that is 50 factorial. We used here n factorial upon r factorial into n minus r factorial. So this is multiplied by p raised to 50 into 1 minus p raised to 50. So p raised to 51 and p raised to 50 gets cancelled. We are left with p here, and here we are left with 1 minus p, since it is 1 minus p raised to 49 and here it is 1 minus p raised to 50. 100 factorial gets cancelled. We can write this as, now we bring numbers on one side and variables on other side, so we can write p upon 1 minus p is equal to 51 factorial into 49 factorial upon 50 factorial into 50 factorial. Now we can write 51 factorial as 51 into 50 factorial into 49 factorial as it is, divided by 50 factorial into, now we can write this as 50 factorial, 50 into 49 factorial. So 49 factorial gets cancelled, 50 factorial gets cancelled. We are left with 51 by 50, which is p upon 1 minus p. So we shuffle the terms. So we get 50p is equal to 51 minus 51p. So therefore, so this is 101p is equal to 51. Therefore, p is 51 by 101, which is option C. So here we saw that the probability of getting a head from a coin was not half. So we can say the coin wasn't fair. So it was too early to judge that probability of half, and we ended up getting probability that it was 50 by 101. That's a correction. Slide oversight. Answer was none of these, since our numerator was 51. So answer is none of these. Next question is, it is a binomial distribution. N is 5. P of x equals 1 is the same as 8 times P of x equals 3. That is, P of x equals 1 is equal to 8 times P of x equals 3. We have to find the value of P. So first we expand this. So we get NCR, that is N is 5, so 5C1, P raised to 1, Q raised to 5 minus 1 is the same as 8 times 5C3, P raised to 3, Q raised to 5 minus 3. That is 5C1 is 5, so 5 into P into Q raised to 4 is equal to 8 times 5C3 is 5 into 4 into 3 by 3 into 2 into 1 into P cube into Q square. 3 gets cancelled, 2 gets cancelled. We are left with, we simplify this term, this equation, we get Q square is equal to 16P square. Taking square root both sides, we can say Q is equal to plus or minus 4P. Now probability cannot be negative, so we can directly say Q is equal to 4P, since it cannot be negative. So Q is 4P. So we form an equation in terms of Q in terms, we get q in terms of p. So now we know q is 1 minus p. So we solve it simultaneously. So we'll get p. So q is 4p. So this will be 4p is equal to 1 minus p. So therefore 5p is equal to 1. So therefore p will be 1 by 5. So the answer is B, 1 by 5. Next question is, a fair coin is tossed. So it is a fair coin, so we can say P is half, Q is half. Let P be probability of getting heads, Q be probability of getting tails. So it is tossed a fixed number of times. So N is unknown. If probability of getting 7 heads is equal to probability of getting 9 heads, then find the probability of getting 2 heads. So it is given that P of x equals 7 is equal to P of x equals 9. So we have to find P of x equals 2. So first we apply the formula. So this is NCR, that is NC7 P, which is half raised to 7, Q raised to n minus 7, that is half raised to n minus 7, which is equal to NC9 half raised to 9 half raised to n minus 9. So this can be simplified as NC7 is equal to, bringing half these terms to RHS, you get NC9 1 by 2 raised to 9 by 1 by 2 raised to 7 into 1 by 2 raised to n minus 9 upon 1 by 2 raised to n minus 7. Bringing these terms to numerator, so you can say NC7 equals NC9 into, now half raised to 9 upon half raised to 7 is half raised to 2 by law of indices. Similarly, we can say this is half raised to n minus 9 minus bracket of n minus 7. This is NC7 equals NC9 into half square into 1 by 2, expanding the brackets, we get n minus 9 minus n plus 7. So this is n of NC9 half raised to 2 into n gets cancelled, we are left with half raised to minus 2. So this term gets cancelled. Since this is positive power and this is negative power, so this is 1 by 2 raised to 2 and 1 by 2 raised to minus 2. So we are left with NC7 is equal to NC9. So now by property of combination we can write NC7 is the same as NC n minus 7. For proof we will check an example. Let suppose this was 5, so let this be 3. So n 5C3, this is the same as, this is 5 into 4 into 3 by 3 into 2 into 1. So this is 10. Now we check NC n minus 7. So this is 5 n minus 7, that is 5 minus 2, 5 minus 3, that is 5C2. So this is the same as 5 into 4 by 2, this is 10. So we can say NCR is the same as NC n minus R, which in this case is NC7 equals NC n minus 7 by property of combination. So we have NC7 is equal to NC n minus 7, but NC7 is also equal to NC9 here. So we equate these two, so we get NC n minus 7 is equal to NC9. So here we can say n minus 7 is the same as 9, so n minus 7 is equal to 9, therefore n is 16. So number of tosses is 16. So we got n. So now we can find P of x equals 2. So therefore P of x equals 2 is NC2 P raised to 2, Q raised to n minus 2. So here it is 16, so 16C2, P raised to 2, Q raised to 16 minus 2. So this is 16 into 15 by 2 into P is half, so half raised to 2 into half raised to 14. So now this is 8. 8 can be written as 2 cube. So 2 cube into 15 into 1 by 2 raised to 16. 2 plus 14 is 16. So we cancel 2 cube. So we get 15 by 2 raised to 13, which is option C. 15 by 2 raised to 13. Next question is, if a coin is tossed 6 times, then probability of getting 4 or more heads is, so what we are supposed to find is probability of getting 4 or more heads from 6 tosses. So it can be either 4 or greater than 4. That is, so since the number of tosses are 6, so it will be P of 4 plus P of 5 plus P of 6. So what we had to find is P of 4 plus P of 5 plus P of 6. So first we'll find the general form for x equals r. So this is NCR P raised to r Q raised to r. So here we assume it to be a fair coin. So P will be half and Q will be half. So now, and n is 6. So we substitute the values. So we get P of x equals r is equal to 6CR half raised to r half raised to 6 minus r. That is the same as 6CR half raised to 6. Now half raised to 6 is 1 by 64. So this is 1 by 64, 6CR. This is the general form for any value of r. So now P of x greater than equal to 4 is P of 4 plus P of 5 plus P of 6. So we substitute the value of r for each of this, taking 1 by 64 common from each term. We get 1 by 64. For r equals 4, it will be 6C4 plus r is 5 in this case, so 6C5 plus 6C6. So this will be 6C4, 1 by 64. 6C4 is the same as 6C2, property of combination. NCR is the same as NC n minus r. This is a property of combination. Plus 6C5 is the same as 6C1. And this is 1. 6C6 or 6C0 is 1. So again, we simplified 1 by 64. Now 6C2 is 15, 6C1 is 6, and it is 1. So finally, we'll get the answer as 11 by 32, which is option B. In this question, n is given as 10, p is 0.8. We are supposed to find p for at most 3 success. That is, x is less than or equal to 3. Since we are told the number of success should be 3 or less than 3. So this is 3 or less than 3, which is the same as p of 3 plus p of 2 plus p of 1 plus p of 0. So first we'll find the general probability, that is p of x equals r, which is now here n is 10, so 10CR p raised to r q raised to 10 minus r. Now p is given as 0.8, which is the same as 8 by 10 or 4 by 5. So therefore q will be 1 minus p, which is 1 minus 4 by 5, which is equal to 1 by 5. So we have p, we have q, we have n. So we can write P of x equals r is equal to 10 CR 4 raised to r by 5 raised to r into 1 raised to 10 minus r upon 5 raised to 10 minus r. Simplifying this, we get P of x equals r. Now 5 raised to r into 5 raised to 10 minus r is 5 raised to 10. So this is 1 by 5 raised to 10. 10 CR 4 raised to r. So this is a general form. So now we add each of these for 3, 2, 1, 0. So P of x less than equal to 3 is P of 0 plus P of 1 plus P of 2 plus P of 3. So we substitute the value of r for each of these. We get in this case r is 0, so this will be. So first we take 5 raised to 10 common, 1 by 5 raised to 10 common. So this will be 10c, r is 0, so 10c 0, 4 raised to 0 plus 10c1, 4 raised to 1 plus 10c2, 4 raised to 2 plus 10c3, 4 raised to 3. Again 5 raised to 10, 10c0 is 1, 4 raised to 0 is 1. So 1 into 1 plus 10c1 is 10, 4 raised to 1 is 4. So 10 into 4 plus 10c2 is 10 into 9 by 2 into 4 square is 16 plus 10c3 is 10 into 9 into 8 by 3 into 2 into 4 cube, that is 64. That is 1 by 5 raised to 10. 1 plus 10 into 4 is 40 plus this term is 45 into 16 plus this is 120 into 64. So multiplying this term, we get the final answer as 8361 by 5 raised to 10, which is option C. The next question is, it is given as n is 9, n is 9, p is 0.8, that is 4 by 5. So therefore q will be 1 minus p, which is 1 by 5. It is given that p of x greater than equal to 6 is 4 raised to 7, 5 raised to 9 into k. So we have to find the value of k. So first we'll find p raised to x greater than equal to 6, then we'll compare it with RHS. So p of x greater than equal to 6 is p of 6 plus p of 7 plus p of 8 plus p of 9. Since number of trials is 9, so we'll stop at 9. So now general form for probability of x equals r is NCR, that is 9CR, P raised to R, that is 4 by 5 raised to R, into Q, that is 1 by 5 raised to n minus R. This is the same as 1 by 5 raised to 9 into NCR. This is similar to the previous sum. So NCR, 9CR into 4 raised to R. So this is a general equation. So we'll substitute the values of R for each of them. So this will be P of x greater than equal to 6. This is equal to P of 6 plus P of 7 plus P of 8 plus P of 9. So P of 6 is, we substitute R as 6. And first we take 1 by 5 raised to 9 common. So 9C6, 4 raised to 6 plus P of 7 is 9C7, 4 raised to 7 plus 9C8, 4 raised to 8 plus 9C9, 4 raised to 9. Now we take 4 raised to 6 common to simplify the addition. So we get 4 raised to 6 by 5 raised to 9. 9C6 is the same as 9C3 by using this property. NCR is the same as NCn minus R. We use this property here. So this is 9C3, 4 raised to 6 is taken out common, so it will be 1 plus 9C7, which is the same as 9C2 into 4, since 4 is left out, plus 9C8, which is the same as 9C1, and what we are left with is 4 square plus 9C9. 9C9 is the same as 9C0, which is 1. So 9C0 into 4 is to 9, that is, so 4 is to 9 divided by 4 is. So now we further simplify, we get 4 is to 6 by 5 is to 9. So 9C3 is 84 plus 36 into 4 plus 9 into 16, 4 square is 16 plus 1 into 4 cube, that is 64. So you get 4 is to 6 upon 5 is to 9 into 436. So now we can see 4 can be taken out common from this term. So we take 4 common. We get 4 is to 7. So 436 divided by 4 is 1. This will be 3. This will be 109 actually. So this will be 109 and this is 5 raised to 9. So if we compare it with RHS, so there is 4 is to 7, 5 is to 9. So instead of K, we have 109. 109. So comparing the RHS, we can say K is equal to 109. So our answer is A, 109. The value of K is 109. So in this sum, N is given as 20. P is 0.1, that is 1 by 10. We have to find P probability of X greater than equal to 1. We are given that we have to find probability of X greater than equal to 1. So probability of X greater than equal to 1, that is probability of at least one success, is total probability, that is sum of all probability, which is 1, minus probability of no success, that is probability of X equals 0. That is 1 minus none rule. So probability of at least one success, that is X less than, greater than or equal to 1, is equal to 1 minus P of X equals 0. So we'll find P of X equals 0. So this will be 1 minus P of X equals 0 is N is 20. So 20 CR, that is 0. P, that is 1 by 10 raised to R, that is 0. Q, now Q is 1 minus P. So 1 minus P is 1 minus 1 by 10, which is 9 by 10. So Q is 9 by 10. So this will be 9 by 10 raised to N minus R, that is 20 minus R. So this is 1 minus 20C0 is 1 into anything raised to 0 is 1. And this will be 9 raised to 20 upon 10 raised to 20. So we can write this alternatively as 9 by 10, which is 9 by 10 raised to 20. So this will be 1 minus 9 by 10 is 0.9, so 0.9 raised to 20. So the answer is C, 1 minus 0.9 raised to 20. In this question, N is given as 10, P is 0.5, that is half. So therefore Q will be 1 minus P, which is also half. So we have to find P of probability of X greater than equal to 7, which is the same as probability of 7 plus P of 8 plus P of 9 plus P of 10. So first we'll find the general probability, that is P of X equals R. So this is NCR, this is where N is 10. So 10CR, P raised to R, P is half. So P raised to R, Q, which is also half, raised to N minus R, that is 10 minus R. So half raised to R into half raised to 10 minus R is half raised to 10. So this will be 10CR, half raised to 10. So we substitute, we use this general form and we substitute it for various values of R. We get P of X greater than equal to 7 is equal to P of 7 plus P of 8 plus P of 9 plus P of 10. So for R equals 7, now we take 1 by 2 raised to 10 common. So for r equals 7, so we have 10c7 plus 10c8 for r equals 8. Similarly 10c9 and 10c10. 1 by 2 raised to 10. 10c7 is the same as 10c3, property of combination. NCR is the same as NCn minus R. We use this property. Plus 10c8, so 10 minus 8 is 2, so this is the same as 10c2 plus 10c1 plus 10c0. Since 10 minus 9 is 1, 10 minus 10 is 0, and 10 minus 7 is 3. So now it is easier to find the combination. So 1 by 2 raised to 10. 10c3 is 10 into 9 into 8 by 3 into 2, plus 10c2 is 10 into 9 by 2, plus 10c1 is 10 and 10c0 is 1. So this is 2 raised to 10 is 1024. So this is 1024. This is 120 plus 45 plus 10 plus 1, which adds out to be 176 by 1024, which is option D. So the answer is D, 176 by 1024. This one is similar to the previous sum. N is given as 10, P is 0.5, which is half. So therefore Q is also half, that is 1 minus P, which is also half. We have to find P of x greater than equal to 9. So this will be P of 9 plus P of 10, since the number of trials is 10. So it will stop at 10. So we have to find P of 9 and P of 10. So P of 9 is, so first we'll find the general form for probability. So P of x equals R is NCR, that is 10 CR P, that is half raised to R, into Q, which is also half raised to N minus R, that is 10 minus R. This is the same as 10 CR 1 by 2 raised to 10. So we substitute the general form. So this will be P of 9 plus P of 10. We take 1 by 2 raised to 10 common. One by 2 raised to 10 common. So P of 9 is, put R equals 9, so 10C9 plus P of 10 is 10C10. So 10C9 is the same as 10C10, 10C1, 10C1 and 10C10 is the same as 10C0. Property of combination, NCR is equal to NCn minus R. So 10C1 is 10 and 10C0 is 1. So this will be 10 plus 1 by 2. 2 raised to 10 is 1024. So this will be 11 upon 1024, which is option C. Next question is, if a fair coin is tossed 5 times, then probability of getting at least 2 heads is, now it is said that it is a fair coin. So P, we can say P is probability of getting heads is half and probability of getting tails is half. So what we are supposed to find is P of x at least 2. So it will be greater than or equal to 2. N is 5. So we can write this as, now probability P of x greater than or equal to 2 is the same as total probability minus P of x less than 2. So here we are saying we should get at least 2 heads, that is 2 or more heads. This is 1 minus total probability minus probability that it will get less than 2 heads, which does not include 2. So this will be 1 minus P of x less than 2 is P of 1 plus P of 0. That is probability of getting 1 head or 0 heads. So we'll find both these two to simplify the equation, the problem. So first we get the general form P of x equals R, which is N is 5, so 5CR, P raised to R, that is half raised to R, Q raised to N minus R, that is half raised to 5 minus R. So this is 1 by 2 raised to 5 cr. So this is the general form. Substitute it here. So we get p of x greater than equal to 2 is 1 minus p of 1 in brackets plus p of 0. This is 1 minus p of, we take 1 by 2 raised to 5 common. So p of 1 is, put r equals 1. So 5c1 plus 5c, r is 0, so 0. It is 1 minus half raised to 5. 5c1 is 5, 5c0 is 1. So 1 minus 2 raised to 5 is 32 and 5 plus 1 is 6. So 6 by 32. So this can be simplified as 1 minus 3 by 16. So this is 13 by 16, which is option C, 13 by 16. Now this is a word problem. It states workers in an industry have 10% chance of suffering from an occupation disease. Probability that out of 6 workers, at least 5 will catch the diseases. So now n is 6, number of workers is 6, and there is a 10% chance of the worker catching a disease. So P is, let P be the probability of catching the disease, suffering from the disease. So this is 10%, which is 1 by 10. Therefore, probability of the worker not having the disease is Q, which is 1 minus P, which is 9 by 10. So we are supposed to find the probability that at least 5 workers will suffer from the disease. So that is P of X 5 or more. So greater than equal to 5. So this is equal to P of 5 plus P of 6, since we have to find out of 6 workers. So first we find the general form. So P of X equals R is NCR. In this case we have N equals 6. So 6 CR P, which is 1 by 10 raised to R, into Q, which is 9 by 10 raised to N minus R, that is 6 minus R. So this is 1 by 10 raised to 6 CR into 9 raised to 6 minus R, 9 raised to 6 minus R. So we substitute the general form. We get P of X greater than equal to 5 is equal to P of 5 plus P of 6, which is the same as, now we take 1 by 10 raised to 6 common. So 1 by 10 raised to 6, 2. Now put R equals 5. So 6C5, 9 raised to 6 minus 5 plus 6C6, 9 raised to 6 minus 6. This is 1 by 10 raised to 6. 6C5 is 6 into 9 raised to 6 minus 5 is 9 plus 6 is 1, and 9 raised to 6 minus 6 is 9 raised to 0, which is also 1. So we can write this as 9 to 6 is 54, and this is 1. So this will be 55 upon 10 raised to 6. That is 6 times 0. So 1, 2, 3, 4, 5, 6. So dividing throughout by 5. So we can simplify this as 11 by 2 lakhs, which is option 8. Hens of a certain breed lay eggs 5 days a week. On an average, a poultry keeper with 5 hens of this breed expects to get at least 4 eggs per day. Then in season of 100 days, his wish will be fulfilled on. So we have to find the number of days when his wish will be fulfilled. That is we have to find probability that at least 4 eggs are laid. At least 4, that is P of X is greater than equal to 4 eggs for each day. So P of X is greater than equal to 4. This is what we have to find. So what we have is a hen can lay eggs 5 days per week. That is probability that a hen will lay egg is P, which is 5 days per week, and a week has 7 days. So probability that one hen is laying an egg is 5 by 7. So this is one part. One hen lays egg with a probability of 5 by 7 days. So probability that it will not lay an egg is 1 minus P, which is 1 minus 5 by 7, which is 2 by 7. So out of 7 days, it will lay eggs for 5 days. So we got P, we got Q. What is asked is we have to find the probability that he gets 4 eggs every day. So now he has 5 hens. So he expects to get one egg from each hen, and he wants at least 4 eggs. That is 4 or 5 eggs per day. So he expects 4 to 5 hens to lay eggs per day. So X is number of eggs laid per day. So P of X greater than equal to 4, which is the number of eggs per day, will be P of 4, that is for probability that 4 eggs lay an egg, that is he gets 4 eggs, or plus P of 5, that is he gets 5 eggs, that is all the 5 hens lay an egg. So we have, so in this case, number of trials, that is number of hens is 5. Since at most he can get the number of most eggs he can get per day is 5. Since there are 5 hens, sorry. So he has 5 hens, so at most he can get is 5 eggs per day. But he wants at least 4. So what we'll be finding is P, or probability that X is 4 or greater than 4. And it has a maximum value of 5, which is the number of hens. That is maximum number of eggs which he can get. So what we got so far is n is 5, maximum number of eggs, that is equal to number of hens. P was one hen had a probability of laying an egg for 5 by 7 days, 5 by 7. So P was 5 by 7. So Q was 2 by 7. So probability that X equals R is, using the general form, is NCR, that is N is 5 CR, P raised to 5, P raised to R, that is 5 by 7 raised to R, Q, that is 2 by 7 raised to N minus R, that is 5 minus R. This is 1 by 7 raised to R, 1 by 7 raised to 5 CR, 5 raised to R, 2 raised to 5 minus R. So we substitute the general form in this. So we get P, probability that the farmer gets at least 4 eggs is P of X greater than equal to 4, which is the same as probability of getting 4 eggs plus probability of getting 5 eggs. So this is, so we take 1 by 7 raised to 5 common. For R equals 5, we have 5C4, 5 raised to R, that is 4, plus 2 raised to 5 minus 4, plus for R equals 5, 5C5, 5 raised to 5, 2 raised to 5 minus 5. So this is 1 by 7 raised to 5, 5C4 is 5, 5 raised to 4, plus into 2, plus 5C5 is 1, 2 raised to 5 minus 5 is 2 raised to 0, which is also 1. So into 1 into 5 raised to 5. Now we take 5 raised to 5 common, since 5 into 5 raised to 4 is 5 raised to 5. So 5 raised to 5 upon 7 raised to 5 is 2 plus 1. So this is 3 into 5 by 7 raised to 5. Now it is given that 5 by 7 raised to 5 is approximately equal to 0.1859. So this is 3 into 0.1859. So multiplying this, will be getting 0.557, which is almost the same as 0.56. So this is the probability, that is 56 by 100 is the probability that he'll be getting an egg, he'll be getting at least 4 eggs per day. So for 100 days, this is for 1 day. So for 100 days, it will be 100 times probability of x greater than equal to 4. So this will be 100 into 56 by 100, which is 56 days. So in 56 days, his wish of getting at least 4 eggs per day will be fulfilled. So the answer is B, 56 days. As an answer to a question, 2 options are given and only one of them is correct. So probability of getting an answer correct is 1 by 2. So let P be the probability of getting the correct answer. So P will be 1 by 2. So naturally Q will be also 1 by 2. So there are 2 options in a question and only one of them is correct. So probability of getting 6 answers right out of 10 questions is 1. So what we have to find is P of x greater than equal to 6. That is probability of finding 6 or more than 6 answers right. So this will be P of 6 plus P of 7 plus P of 8 plus P of 9 plus P of 10. So first we'll find the probability of finding an answer right. So we have n equals 10. So 10 questions are attempted and R is number of right answers. So probability of getting an answer right, R times is 10 CR, P is half, so P raised to R, Q raised to n minus R, that is 10 minus R. So this will be 1 by 2 raised to 10, 10 CR. So this is P of x equals R. So probability of x greater than equal to 6, that is getting at least 6 answers right, is P of 6 plus P of 7 plus P of 8 plus P of 9 plus P of 10. So taking 1 by 2 raised to 10 common from all the terms, we get 1 by 2 raised to 10. Putting R values for each of them. So 10C6 plus 10C7 plus 10C8 plus 10C9 plus 10C10. Now 10C6 is the same as 10C4. Since we are using the property NCR is the same as NC n minus R. We are using this property. So 10C6 is the same as 10C4. 10C7 is equal to 10C3. 10C8 is 10C2. 10C9 is 10C1. And 10C10 is 10C0. Writing this again. So 10C10 is 10C0. 10C9 is 10C1. 10C8 is 10C2. 10C7 is 10C3. And 10C6 is 10C4. So P of x greater than equal to 6 was 1 by 2 raised to 10. So we had 10C6 which is 10C4 plus 10C7 which is 10C3 plus 10C8 that is 10C2 plus 10C9 that is 10C1 plus 10C10, which is the same as 10C0. So this is 1 by 2 raised to 10. 10C4 is 210 plus 10C3 is 120 plus 10C2 is 45, 10C1 is 10 and 10C0 is 1. Adding up these terms, we get this is 386 by 1024. So dividing throughout by 2, we get 193 divided by 512, which is option C. Next one is Jewish chance of winning a single game against Roshali is 3 by 4. Probability that in a series of 5 games, Jew wins at least 3 games is, so probability that Jew will win is 3 by 4. So P is 3 by 4. So therefore Q will be probability of losing is 1 minus P, which is 1 minus 3 by 4, which is 1 by 4. So Q is 1 by 4, P is 3 by 4. So number of games played is 5. So N is 5. And he is supposed to win at least 3 games. So probability of winning at least 3 games is P of X greater than or equal to 3, which is the same as probability of winning 3 games plus probability of winning 4 games plus probability of winning all the 5 games. So general probability expression is P of X equals R is N, which in this case is 5. So 5 CR. P is 3 by 4. So 3 by 4 raised to R. Q, that is 1 by 4 raised to 5 minus R. This is 1 by 4 raised to 5. 5 CR. 3 raised to R. So this is the general form. So substituting this here, we get P of X greater than or equal to 3 is P of 3 is, now we take 1 by 4 raised to 5 common. So P of 3 is put R equals to 5. So 5C3, 3 raised to 3 plus 5C4, 3 raised to 4 plus 5C5, 3 raised to 5. Now we take 3 raised to 3 common from all the terms. So 3 raised to 3 upon 4 raised to 5 into. So we are left with 5C3. So 5C3 is the same as 5C2 by using this property. NCR is NC n minus R. So 5C2 is 5 into 4 by 2, which is 10. So 5C3 is 10 plus 10 into 1 plus 5C4 is 5. And we are left with 3 after we took 3 raised to 3 common. Plus here we are left with 3 square into 5C5 is 1. So this is 3 cube, that is 27 by 4 raised to 5 into sum of these terms is 34. So solving this further, we finally get 459 by 512, which is option B. Now the next question is, if a fair coin is tossed 9 times, the probability that it shows heads in the first 4 tosses and tails in the last 5 tosses is, it is a fair coin, so we can say P is half and Q is half. And number of tosses are 9. So N is 9. So we are supposed to get heads for first 4 tosses and tails in last 5 tosses. So the arrangement will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So arrangement will be such that it is head, heads, 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 tails, 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 tails. And this will be in AND condition. That is, we are supposed to get this successively. So we'll be multiplying the probability of each of them. So probability that we'll get a head is P. Next should also be a head. So into P into another head. So P into P. So now, but next one should be tail. So probability of getting a tail is q. So next we multiply it with q, and this goes on further for 5 terms. So q into q into q into q into q. So this will be 5 times and this will be 4 times. These are done successively, so we are multiplying it. This can be written as p raised to 4 and this can be written as q raised to 5. And this is the probability p of x, say. So p is half, so half raised to 4 into q is also half, so half raised to 5. So this will be 1 by 2 raised to 9, which is 1 by 2 raised to 2 raised to 9 is 512. So this is 512. So the answer is A, 1 by 512. And with this, we are done with level 1 question. In the next part, we'll be dealing with level 2 questions of binomial distribution.